Determine if the triangles below are similar. If yes, state which method. I have a friend that says similar. So let's determine if they're similar. There's three ways to determine if they're similar or similar. If two of the angles in the triangles are the same, not within each triangle, but let's say this is triangle A and triangle B. If triangle A has an angle that is the same as an angle in triangle B, and then triangle A has another angle that's the same as a second angle in triangle B, then you've got similar triangles. This is also called angle, 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 because if two angles are the same, all three are the same, because they have to add up to 180. Another way is if all the sides are in a ratio. So in other words, here's triangle ABC, the sides, and here's triangle DEF. If A to D equals B to E equals C to F, then those are similar triangles, or similar, as my friend would say. Then there's also side, angle, side. So in other words, if A is to D and B is to E, those ratios are the same, and the angle between them, whatever that angle is the same, then it's side, angle, side. You have to watch out because triangles could be spun around. The first two sides you check may not give you the right ratio, and you'll have to check other sides or other pairings of sides, and I'll show you how this works right now. So I look at these triangles in A, and of course I have a vertical angle, so those angles are equal. So now let me see if the ratio of this side to this side equals the ratio of, I'll put these in red, of this side to this side. 81 over 42, that's a ratio, equals 63 to 54. You've got to be consistent. I don't know, I'll call this the big triangle and this the little triangle. So it's really the ratio of big to little. So let's see, 81 over 42, I don't think I can divide that by anything. So 81, in other words, I can't simplify it. That's 1.93, and then 63 to 54 is 1.16. So those ratios aren't the same, but I can try the other pairing. Let me try 81 to 54 equals 63 to 42. So in other words, you may try the triangles one way. You think the 81 side corresponds to the 42 side, and the 63 side corresponds to the 54 side. Okay, but then that one doesn't work. Well, then see if the 81 side corresponds to the 54 side, and the 63 side corresponds to the 42 side. Check those ratios. So let me check it on here. 9 goes into 81 9 times, 9 goes into 54 6 times. You can just do 81 divided by 54 and see if it equals 63 divided by 42. The answer will be yes. I think they both come out to 0.6666 going on forever. 7 goes into 63 9 times, 7 goes into 42 6 times. So see, they both equal 9/6. It can be simplified further, but I found that they're the same. So therefore, I have this side has, and ratio to this side is the same as this side's ratio to that side, and the same angle between them. So this one is yes, side, angle, side. Look at B. Whenever two triangles, write this on your cheat sheet, whenever two triangles are drawn such that the second smaller one just has a side of it that's parallel to one of the sides of the original big triangle, those are similar triangles. And here's why. I'll call this A, and I'll call this B. And I'll call this big thing C, and I'll call this little thing D. So I'm going to do small to big. And notice this angle is in both triangles. So obviously it's the same. It's the same angle. The little triangle has it, and so does the big triangle have it. So let me see if the sides around that angle are in the same ratio. So I want the ratio of small to big. B to A equals the ratio of D to C. And that is the case. Whenever you draw a parallel line to one of the sides of the triangle, that little part is going to be, they're similar triangles with the little to the big equal to the little to the big. So again, this is side, angle, side. Here's the side of the little triangle, corresponds to the big triangle, the angle in between them. Side of the little triangle corresponds to the side of the big triangle, side angle side. I'm going to see if there's another method I can do on that one when I'm done with everything, but we'll try that at the end. Now check this one out. This one, I don't know which side is supposed to correspond to which other side. This triangle may be rotated to get the second triangle, the one on the right. Don't know, but in similar triangles, the ratio of the inner sides is the same too. So in other words, if I have a triangle like this is a 3, 4, 6 triangle. And this one is a 6, 8, 12. So notice, here's a side, here's a side. 3 to 6 equals 4 to 8. Oh, not 3. Yeah, 3 to 6 equals 4 to 8. And 3, 6 equals 1 over 2. I can simplify it. 4 goes into 4 once, 4 goes into 8 twice. So see, the ratio is 1/2. But I could also rotate that second triangle. What if I rotate it and I do 3, not 3, I want to do 6, 8, 12. See, now this side actually corresponds to that side. And I'll do the next one in red. This side corresponds to this side, and I'll do the third one in blue. This side corresponds to that side. So it's been rotated around. How do I know that? I don't know it. So watch this. The inner ratios, I'll find an inner ratio that's the same. I'll do with this first triangle, 3 to 4, 3 over 4 equals. Now, notice the smaller number is on top, so I'm not going to do 12 to 8 or 12 to 6. Let me try 6 to 8. 2 goes into 6 3 times, 2 goes into 8 4 times. See, it's equal. So I found a ratio in the second triangle, 6 to 8, that's equal to 3 to 4. So now I know that those two triangles are similar, and this side with the 3 is going to be corresponding to that side, 3 to 6 equals this side, 4 to 8. And if I knew that this angle is equal to this angle, then I'd have side angle side. So I'm going to do the same thing with these. First, I'm going to try to figure out if they're similar. If they are, then I'll figure out which sides correspond and what the angle is between them. But in this case, I don't have an angle. I have to have all three sides similar. In this case, I need side, side, side. So the only way, because I don't know angles, is going to be side, side, side. So I've got to figure out which triangle or which sides correspond. So let me try within the first triangle, 24 to 28. Excuse me. So notice the smaller numbers on top. I'll try 10 to 18, because that's got the smaller number on top. I'll try 10 to 16, and I'll try 16 to 18. I'm not going to try 18 over 16, because that's got the bigger number on top. I'm not going to try 18 over 10. That's got the bigger number on top. But if I can find that, then I can check the other two sides. But if I don't find this, if I don't find a corresponding set, this side to this side, 24 to 28, if I don't find that in the second triangle, that ratio, then they're definitely not similar. So 24 to 28, let's see, 4 goes into 24 6 times, 4 goes into 28 7 times. So let's see, 2 goes into 10 5 times, 2 goes into 18 9 times. That doesn't equal 6 sevenths. 2 goes into 10 5 times, 2 goes into 16 8 times. That doesn't equal 6 sevenths. 16. 2 goes into 16 8 times, 2 goes into 18 9 times. That doesn't equal 6 sevenths. I didn't find the same inner ratio. That means these triangles are not similar. If I had found one in the second triangle on the right that equaled 6 sevenths, then I would know that those things paired up. But in this case, it didn't happen. So those are not similar. Now I've lost my mouse. There's the mouse pointer. I'm trying to get down to the bottom so I could scroll. There we go. Scrolling and scrolling. Okay, notice again, well, I guess it doesn't show us that these two lines are parallel, but it does give us some numbers here. This whole side is 52.5, and just this little part is 15. Well, what does that leave for this side of this little triangle? 52.5 minus 15, 37.5. So this little one is 37.5. So let me try little to big. And then notice this angle right here. That angle is the same in both triangles. So I've got the angle. I've got to see if this little side, 37.5, the ratio of that to the big side, 52.5. So little to big equals 37.5 to 52.5 equals the same thing on this side, the other side of that angle, 25. And what's the whole thing there? The whole thing is 35. Now again, you can just do the division. I'm going to extend my space a little bit just so I have a little bit more room. You can throw that in the old calculator and do the division and see what it comes out to. I think you'll find out they come out to be equal. But let's see, 25 over 35, 5 times 5 is 25, 5 times 7 is 35. So now let's look at 37.5 over to 52.5. Is there some number I can divide both by to get 5/7? Well, let's see. 37.5 divided by 5 is 5 times 7 is 35. 5 times 5, 7.5. So if I divide the top, 37.5 divided by 7.5 is 5. 52.5 divided by 7.5. I'll move that decimal, move that decimal. Let's see. 7. 7 times 7, 49, 50, 51, 52 is 7. Yeah, so 37.5 over 52.5 is 5/7, and so is 25 over 35. So the ratio of the corresponding sides is the same, and the angle between them is the same. Yes, these are congruent, or not congruent, these are similar, and it's side angle side. You could have also just 37.5 divided by 52.5, see what that number is. And then on your calculator, 25 divided by 35, see what that number is. They'd be the same. So you know these are similar triangles because that angle's the same. The ratio of small to big, or big to small, whichever way you want to say it, is equal to the ratio of small to big. I did small to big, or little to big. All right, let's go to the next one. This one, I'm not given any side, so I'm going to have to see if I can find angle. Well, certainly, here's 65, so I've got one, but then there's 59 and 56. But wait a minute, what's this third angle? What's 65 plus 56? 121. What's 180 minus 121? 59. So the third angle in this triangle is 59. Oh, look. I'll put a box around it. Well, I've already got 65. I've got 59, so I've got angle. And the third angle in this one is going to be 56. Because 180 minus 65 minus 59, work it on your calculator, is equal to 56. So those two are similar, angle. The next one, I don't have any side lengths, so I am going to, I see these two lines are parallel. That's what these arrows mean inside the line. It means they're parallel, so I'm going to extend them like that. And then this is just for visual. I'm going to extend this one in red, and I'm going to extend this one in blue, just for visual. So notice the black lines are parallel lines, and the blue line is a transversal that goes between them, and the red line's a transversal that goes between them. What do I know about transversals? I'm going to look at the blue line. This angle is a small angle, and that's going to be equal to that angle, a small angle. Or, if you know, those are alternate interior angles. So those are equal. I've got one angle inside the triangles that are the same between the triangles. Now look at the red transversal between the black parallel lines. this angle and this angle are alternate interior angles. Or again, they're the small angles of that set, so they're equal. Well, now I'll call this triangle A and I'll call this triangle B. In triangle A, I have a side angle that's equal to an angle in triangle B. In triangle A, I have a second angle that's equal to a second angle in triangle B. Angle, angle again. So F is yes, angle, angle. And that's it for that worksheet.